Hello, we're going to talk a little bit about functions so that you can get ready for your test. So these are the various things that we've been looking at on these functions. So let's start by talking about graphing a function. All right, so when you graph a function, you want to, you could either solve for y or you could go and plug the points in by covering up the x and the y. So I prefer that way. So I like to let's cover up the y and solve for x. So you've got negative 2x is equal to 8. So once you divide by negative 2, you're going to get x is equal to negative 4. That's your x-intercept. So let's go and graph that at negative 4, our x-intercept, and then let's cover up the x and solve for y. So I'm going to cover up my x. Oh, look at that. Super easy, right? Y is equal to 8. That's my y-intercept. So I'm going to graph my y-intercept at 8. And then really all you do is connect your dots. We don't care so much in Algebra 2 what the slope is. We don't care about all that stuff. We do care about the intercepts, okay? And so it's a lot easier to do that instead of doing the slope-intercept form. But suppose you wanted to, okay? Suppose you wanted to just keep solving for y. It's fine, all right? Add 2x to both sides. All right, these cancel out. You get y is equal to, now you write your x term first, 2x plus 8. All right, y-intercept is 8. Slope is 2, so I'm going to go up 2 and over 1 to get to my next point. I didn't graph it quite right. Or you can put that in your calculator and you can plot some points, okay? So you can enter the function into your calculator and then you can plot points. All right, so let's try another one. All right, not that one. Try this one. All right, 4x minus 3y equals 24. All right, cross out your y, including the sign in front of it. Solve for x. So 4x equals 24. Divide both sides by 4, and you get x is equal to 6. There's my x-intercept. All right, then you want to go and solve for y. So I've got to cross out my x. Don't cross out the negative sign in front of the y because you need that. Divide by negative 3, divide by negative 3, and you get y is equal to negative 8. So I'm going to scroll down and graph that point. All right, now I know my x-intercept and my y-intercept, and I'm going to connect my dots. All right, and there you go. Okay, let's go on. Now, from here, we're going to find domain, we're going to find range, we're going to talk about interval behavior, we're going to talk about all kinds of things. Okay, so let's go on and look at zeros and roots, just to remind ourselves, because we always want to go back to that. Zeros and roots are where it crosses the x-axis. It's also called the x-intercept. We're going to use those a lot in Algebra 2. All right, so I'm going to go on because I want to be able to talk to you about domain and range. These are all the problems that you guys did for homework, so those were the answers if you wanted to go back and check them. Okay, so remember, a function has only one element. All right, so each element of the domain is paired with only one element in the range. Okay, so it has no repeating x's. We've done this a lot, okay? That's an Algebra 1 way of looking at it. All right, if you did the vertical line test, this is actually a function because it's only crossing the graph one time every time you draw a vertical line. All right, so then again, now in Algebra 2, we still talk about domain and range. We just basically have to say it a little bit differently, okay? Domain is x, range is y, but we're going to say it just a little differently, and we're going to talk about like what it can be and what it cannot be. All right, so we use this notation now. We don't list points very often, okay? So if you are looking at this function, y equals negative 2x plus 3, and the domain is between negative 2 and 2, then we're going to talk about all the y values that are between what comes out of that, okay? Many different ways to do this. I'm going to put this in my calculator. This is the easy way to do it, all right? And I'm going to go look for where x is negative 2, because that's where it starts, all right? So if I plug in a negative 2, and then I add that a 3, or I look on my table, I'm going to get a 7 to come out. And then I'm going to go to the other end of that interval, and I'm going to plug in a 2. And when I plug in the 2 and I get that to come out, that's going to give me a negative 1. All right? So now our range is going to be an interval, and we're talking about y, and then y's are going to be between what two numbers? Well, we got to go in number line order, okay? Negative 1 is smaller than 7, so we write it first, and then we put 7 in here, okay? All right, so let's go look at another one. All right, so we remember that means between. All right, what's the range for that when the domain is this? Okay, the other way of doing it, don't go and find it in your table. Just make a table. All right, you could go, no, don't even make a table. You're going to do f of negative 2. What is f of negative 2? So negative 3 times negative 2 minus 1. Well, that gives me, what does that give me? I think it gives me 5. All right, and then I'm going to do f of 4. So f of 4. All right, I'm really just trying to figure out what goes in when I put something in for x, what's going to come out for y. All right, so I've got negative 3 times 4 minus 1. All right, that's going to give me negative 13. All right, so if my domain is that, my range is going to go from negative 13 to, or it's between negative 13 and 5. All right, if you graphed this on a graph, here is what you would be seeing. All right, the graph looks like negative 3x minus 1, so I'm guessing it's probably like, kind of like that if I were looking at the graph. All right, and I only want the domain and range for where x is between negative 2 and 4, okay? So I'm going to maybe put a point at negative 2, wherever x is negative 2, all right? And wherever x is 4, all right, let's say that's a 4 and that's a negative 2. What is all these y values? Well, all these y values go between 5 and negative 13. Okay, that's what we're looking at. Okay, so talking a little bit more about domain and range, all right? So if you look at any straight line, your x values are going to go on and on and on and on and on forever, all right, in both directions. So your domain is all real numbers. And then your y values are going to go on and on and on forever, up and down, right? Because these arrows are telling it's going left and right and up and down. So your range is all real numbers. We don't list them out as points anymore. We got to count everything in between. So when you don't know where they start, you can say they start at negative infinity or infinity, but we don't really use that much in Algebra 2. Sometimes we do, so we'll get back to that in a later date. All right, try graphing this. So you've got f of x is equal to x squared minus 3. Here's what it looks like. Sort of, kind of messed that up. All right, so you got this going on, right? Well, every quadratic with a squared term is going to go on and on and on forever to the left and on forever to the right. So the domain is going to be all reals. But not all the ranges are going to be all reals, because some of the points don't go below a certain point or above a certain point. So let's label this point. That point is called 0, negative 3. All right? And since range talks about y values, we're only going to care about the y value, all right? So something has to do with -3 with the y. Well, is it going to be greater than or equal, or is it going to be less than or equal? Since all of the points are going above -3, then it's going to be greater than or equal to -3. And that's it. That's all you write for that. All right, let's try another one. All right. So we already did that one in class. I want to go further. Okay. What is x not allowed to be on some of these? Okay, you've got some discontinuity going on here. All right. So if you graphed this function right here, and you did in class, but do it again if you need to. All right. It's going to look like this. I gotta see. All right. It's going to kind of come down like that. And then it's going to kind of come across like this, and then it's going to turn, okay? There's a line that it's not crossing, all right? And so if you look at it, you'll see it doesn't cross this line right here, okay? So that's going to tell you what x is not allowed to be, okay? So it could be all reals, right? Because it's going to keep going on forever and ever this way. It's going to keep going on forever and ever that way. But it is not going to touch a certain point, and that point or that line is 5, all right? And you can look at that in your table. Whenever you go and find the number that makes an error sign, that is where it's discontinuous. It's not allowed to be that, okay? So you can look at that in your graph on your calculator, all right? Now on the range, usually, most graphs, all right, are going to be all reals unless there's some kind of endpoint, right? But now, see, this one's going to end up going on forever and ever down to -infinity, and it's going to go on forever, ever up to +infinity. But there's a line it does not cross. So you kind of have to just visualize it. Look at that. It's not crossing that line. What is that y value? Well, it's 0. So the range is going to be all reals except 0. And that's how you have to describe that. Oh, it's time to go. I forgot.